Hi, let me tell you about another great Manning book, Building Reliable AI Systems, Applications and Agents You Can Trust, written by Rush Shahani.
The demo works. The model reasons, writes code, calls tools, and completes a workflow that once looked impossible. Then production starts. A citation is fabricated. A policy answer is wrong. A tool call takes the wrong action. Capability is not reliability. Reliable AI means accurate outputs, safe actions, and durable quality. Frontier models now beat PhD-level averages on science benchmarks and solve many software tasks, but benchmark strength does not equal production reliability. When tests use fresh, unfamiliar code bases, performance drops. That gap is the reliability gap. A stronger model is only the start. Production systems need grounding, evaluation, monitoring, and controls wherever the model speaks or acts. LLMs reshape law, customer service, development, and enterprise operations. Legal platforms speed review and research, but one fabricated citation can cause serious damage. Customer assistants answer faster across languages, but a confident policy mistake can become a company liability. Coding assistants speed up development by 30 to 55%, but generated code still needs review, tests, debugging, and security validation. Enterprise agents raise the stakes by acting inside business workflows. Once AI acts, reliability must include permissions, reversibility, robust tools, escalation, and failure containment. Hallucination is dangerous because it can look like expertise. A legal assistant can invent cases with realistic names, citations, dates, and reasoning. The failure does not crash. It produces a wrong answer that looks right. A hallucination occurs when an LLM generates incorrect, nonsensical, or unfaithful content while presenting it with confidence. LLMs learn patterns and predict one token after another. They know what an authoritative text looks like, but do not verify every claim. Reliable AI is broader than hallucination reduction. A reliable system is accurate, consistent, grounded, fair, efficient, safe, and durable. It fails gracefully instead of guessing. Traditional reliability tracks uptime and error rates. AI reliability adds semantic correctness. Reliability has 3 layers. Reliable outputs, explained in chapters 2 to 5, produce grounded responses. Prompt engineering shapes behavior. RAG grounds answers in documents. Embeddings and vector search find meaning beyond keywords. Fine-tuning adapts behavior and domain conventions when needed. Reliable agents, explored in chapters 6 to 8, act safely. Once AI uses tools, APIs, databases, and workflows, error costs multiply. Agents need auditable reasoning, planning, memory, standard tool integration, error handling, and safeguards. Reliable operations, analyzed in chapters 9 to 11, keep quality alive after launch. Models change, data drifts, and users surprise the system. Evaluation measures faithfulness, relevance, safety, and impact. Monitoring tracks semantic quality, hallucination rates, drift, and satisfaction. Bias, privacy, transparency, and governance matter because discrimination or data leaks make a system unreliable. The toolbox maps techniques to failure modes: model selection, prompt engineering, RAG, vector search, fine-tuning, agent frameworks, tool integration, multi-agent systems, evaluation, and monitoring. Start simple. Begin with prompts. Add RAG for grounded answers, fine-tuning for domain behavior, and agents only when action is necessary. Build evaluation and monitoring from day one, because reliability cannot improve if it is not measured. As AI enters healthcare, finance, legal services, customer operations, and critical infrastructure, the margin for error shrinks. A production system is more than a model. Prompts, retrieval, tools, agents, permissions, deployment, monitoring, and feedback loops can all fail. Reliable systems let organizations automate with confidence, scale with fewer surprises, and earn trust. Model-only teams stall in experimentation and debug failures after launch. Regulation adds pressure because governance applies to systems, not just models. The setup is light: Python 3+, with pip, a code editor, and an OpenAI API key. Most examples use API calls rather than local model hosting, keeping setup simple and costs low.
Get this book at manning.com